This is Kaitlan Tseng doing problem 15 from chapter 4, and it states that a ball is tossed from an upper story window of a building. The ball is given an initial velocity of 8 meters per second at an angle of 20 degrees below the horizontal. It strikes the ground 3 seconds later. So it asks, A, how far horizontally from the base of the building does the ball strike the ground? B, find the height from which the ball was thrown, and C, how long does it take the ball to reach a point 10 meters below the level of launching? So I drew a diagram of the situation, and so you have your building and then you have the ball that's being thrown out. So it comes down at a velocity of 8 meters per second, and this is just its like line of motion, and it's thrown 20 degrees below the horizontal. And here I've designated the positive and negative directions. If you look closer at the initial velocity, I separated it into x and y components. So that is the first thing I'm going to solve for. So the initial x component of the velocity is equal to 8 meters per second squared multiplied by cosine 20 degrees, as you can see from the triangle up here, and that is about 7.518 meters per second. And if you're trying to find the initial y velocity component, it's going to be 8 meters per second times sine of 20 degrees, which is about 2.736 meters per second. So now that we found that, I'm going to go to part A, and that again asks for how far horizontally from the base of the building does the ball strike the ground. So you have your formula that the displacement x is equal to the initial x velocity multiplied by time, and that, if you just plug in the numbers, is 7.518 meters per second multiplied by 3 seconds, because we're given that it hits the ground at 3 seconds, and that is equal to 22.554 meters. And if you go to part B, which asks you to find the height from which the ball was thrown, you're going to use your kinematic that y is equal to 1/2 gravity times time squared plus the y initial t. And again, if you plug in your values, it's 1/2 times negative 9.8 meters per second squared times 3 seconds squared plus negative 2.736 meters per second times 3 seconds. And again, we got this initial y velocity from up here when we calculated it. And it's going to be negative because it's going downwards, which we already designated up here. And that is equal to negative 52.308 meters. So therefore, our height that it's thrown from is 52.308 meters. Okay, and finally for part C, it asks us how long does it take the ball to reach a point 10 meters below the level of launching. So again, we're using our kinematic y equals 1/2 gt squared plus v y initial t. So our displacement in the y direction would be negative 10 meters, which equals 1/2 gravity, which is negative 9.8 meters per second squared, multiplied by time squared, plus negative 2.736 meters per second times time. And if you simplify that, it would be 4.9 meters per second squared, time squared, plus 2.736 meters per second times time minus 10 meters. And that equals to 0, so you get a quadratic function. So what you do is you graph it on your calculator, and you find the intercepts to find t, and you find the one value t that's positive, which is about 1.176 seconds.